Number one, rewrite each of the following expressions in simplest form using positive exponents. So in this lesson, we reviewed our properties of exponents from 8th grade and Algebra 1. So let's get right to it. I have 2x to the negative 2, y to the negative 2 over 4y to the negative fifth. So I've got a 2/4 there that I'm going to take care of first. 2/4 simplifies down to 1/2. Now, I don't have anybody else with an x, so I've got an x to the negative 2. And my y's here. When we divide exponential expressions and they have the same base, they both have a base of y, we can subtract the exponent. So it's really y to the negative 2 minus negative 5. Be careful there because we get y to the third. So how do I deal with x to the negative 2? When I have just a negative exponent, that lets me take it and throw it in the denominator. I take the reciprocal of that. So what's the reciprocal of x squared? Well, that's going to be 1 over x squared. I've got a y cubed up top. So maybe you wrote y cubed over 2x squared as your answer. 3x cubed y all to the negative 1 over x squared y to the negative fourth. So I've got that negative 1 exponent that everyone inside this set of parentheses needs. So I've got a 3 to the negative 1. When I have a power to a power, I multiply x to the negative 3, y to the negative 1, over x squared y to the negative fourth. So that 3 to the negative 1 ends up in the denominator. I've got x to the negative 3 over, so that's really, and that 3 is really like a 1/3. I'm going to leave it like that for now. When I deal with my x's, negative 3 minus 2 is x to the negative fifth. Y to the negative 1 over y to the negative fourth. Subtract negative 1 minus negative 4. Negative 1 plus 4 is a positive 3. So I end up with y cubed over 3. That x to the negative fifth ends up in the denominator. That's my final answer here. Use properties of exponents to determine the value of a such that x to the negative 2 over x to the fifth to the negative 3 all to the negative third equals x to the a. We've got a whole lot going on. Let's start cleaning it up. So on the inside here, I've got x to the negative 2 over a power to a power means I multiply. All right, I've got division. I can handle that. When I divide, I subtract the exponent. So negative 2 minus negative 15. Negative 2 plus 15 is 13. So that's x to the 13 all to the negative 3. Power to a power means I multiply. So I end up with x to the negative 39. So what's the value of a? A equals negative 39. Number 3, explain why x to the 0 equals 1 for all value of x not equal to 0. So, if x to the a times x to the 0, I'm going to say we know x to some power times x to the 0 should give us x to some power because we add the exponents when multiplying with the same base. So x to the a times x to the 0 needs to give us x to the a. X to the a times 1 gives us x to the a. Therefore, x to the 0 must be 1. Because that x to the 0 there needs to be the multiplicative identity. So x to the 0 has to be 1 because I need something times x to the 0 to give me that same thing. So that's why it's 1. The expression 4 cubed times 8 quantity squared all over 2 cubed can be written as 2 to y. So 2 to some power. Find the value of y. So I need to get everything in terms of 2 here. So 4 is really 2 squared. 8 is really 2 cubed. So if I just make everything in terms of 2, get everyone with a common base here, that'll make my life a little bit easier, and then I can just use my properties of exponents. 2 squared cubed power to a power means you multiply. I'm going to add those exponents together first because I really have 9 2's inside of there. Sorry, that's squared. Power to a power, again, I'm going to multiply. Division, I'm going to end up subtracting. So I end up with 2 to the 15th. So y equals 15. Explain how you got there? I got a base of 2 and used properties of exponents.